Hello, good morning, friends. Today we discuss about the metallic radius, that is we called as a crystal radius. What is meant by metallic radius? The metallic radius metals, alkali metals are present in the group first, and alkaline earth metals are present in the group second. Then that metals forms the crystals, and we have to calculate the metallic radius and crystal radius. This is used for the metal atoms and which is assumed to closely packed spheres in the metallic crystals. That metallic crystals are very closely packed and in a space in the metallic crystals. The metal atoms are supposed to touch one another in the crystals, and the crystal radius is defined as the one half of the distance between the nuclei of two adjacent metal atoms in the metallic closed packed crystal lattice, in which metal exhibit a coordination number of 12. That is, for example, the internuclear distance between two adjacent atoms, for the sodium atoms in a crystals about the 10 to 15% higher than that of the single bond covalent radii. Since the metallic bonds which controls the proximity of the metal atoms to one another in the metallic crystal is not localized bond between the bonded atoms as is covalent bonds. That is, the metallic bondings are very closely packed spheres in the metallic crystals, and the definition of the metallic crystal radius is the one half of the distance between the two nuclei of adjacent metal atoms in the metallic closed packed crystal lattice. Anyways, that metal atoms exhibits a coordination number is 12. That is, the metal atoms, already we discuss about the sodium metals. The sodium metal atom in a crystal of sodium metal atom, that is the 3.80 angstrom unit only, and the atomic radius of the sodium metal is 3.80 divided by 2 is equal to the, that is the 1.90 angstrom unit metallic radii. That is metallic radius of sodium metal atom, metal crystals. Metallic radii are the about, that is 10 to 15%, that is about 10 to 15% higher than that of the single bond covalent radii. Since the metallic bond which controls the proximity of the metal atoms to one another in the metal crystals is not localized bond between the bonded atoms as is in covalent bond. Covalent bonds, the metallic atoms are closely packed, and covalent bonds are not closely packed or not localized bond between the two atoms as in covalent bonds we discuss about. And then the metallic radii are the similar than that of the van der Waals radii, since the bonding forces in the metallic crystal lattice are much stronger than that of the van der Waals forces. Metallic crystals are much stronger than that of the van der Waals forces. Then we discuss about the van der Waals radii. Van der Waals is the name of the scientist, and the radius that forces van der Waals forces are generally occurred in the hydrogen bondings. Then the van der Waals radii definition, it is defined as the one half of the distance between the nuclei of two adjacent identical atoms. Identical atoms, that is the hydrogen. Identical atoms belonging to the two neighbor molecules of an elements in the solid state. For example, in hydrogen bonding, H2O bonding, in the H2O, that is the hydrogen bonding is takes place. Then the van der Waals radii are much larger. These radius are much larger. That's why these bonding is not tightly binding with each others, and the van der Waals radii are larger than that of the metallic radii. That is, the van der Waals radii are much larger than that of the covalent radii because of the orbital overlapping within a bond ring, and the brings the atoms much closer together. In the covalent bond, that atoms are much closer than that of the van der Waals radii. Van der Waals radius is much longer than that of the covalent radius, than that of the metallic radius, than that of the ionic radius. Then the shortest distance between the chlorine atoms of adjacent molecule, that is the carbon tetrachloride, is 3.60 angstrom unit, giving to the chlorine van der Waals radii of 1.80. Here the internuclear distance is 3.60 angstrom unit, and the two chlorine and the van der Waals radius is 1.80 angstrom units. Two adjacent molecule radius is that is the 1.80. It means that the van der Waals radius is much larger than that of the covalent radius, metallic radius, ionic radius, and their bonds are not tightly binding with each other. That's why these forces are much, that is, lesser stronger than that of the covalent radius, ionic radius, metallic radius. Then we discuss about the ionic radius. Ionic radius may be defined as the distance between the nucleus of an ions, that is NaCl, NaOH ions, and point out to the which the nucleus has influence on its electron cloud. The value of ionic radius or the ionic radii of S and P block elements are given in the table. That is, in the first group elements, alkali metals are present. In the second group elements, that is alkaline earth metals are present. In the third group, boron family is present. Then fourth, carbon groups. Then fifth, nitrogens. Sixth, oxygen. Seventh, fluorine, chlorine. All the halogen atoms are present. In the radius, the ionic radius, factor affecting on the magnitude of the ionic radius. What are the factors affecting on the ionic radius? First factor is the coordination number. With the increase of coordination number, the inter-ionic distance and hence the ionic radius are also increases. It means that the coordination number is increases. Then increase the inter-ionic distance, and hence the ionic radius is also increases. Then the S block elements and the P block element. In the S block element, hydrogen, first group elements, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Then second group elements, beryllium, magnesium, calcium, strontium, barium, and radon. All these elements are present in the first group and the second group elements. Then we discuss about the ionic radius, how the ionic radius is decreases or the increases. From in the first group elements, from top to bottom the ionic radius is increases. In the first group, ionic radius H plus ions 0.29 and hydride ion, that is H minus ions 1.60. Lithium plus 0.60, sodium plus, that is the ions having the 0.93, potassium plus ions, that is the 1.33, rubidium plus 1.48. It means that the ionic radius from top to bottom, the ionic radius is increases in the first group elements. In the second group is also same happen in case of the second group, that is the beryllium 2 plus ions. The valency of the beryllium is 2. It means that if the by donating of 2 electrons, the ionic radius of beryllium atom is 0.31, then magnesium same case, by donating of 2 electrons, magnesium having the Mg2 plus having the ionic radius is 0.63, and calcium is also 0.99. Strontium ionic radius 1.13, beryllium 2 plus, it means that the ionic radius 1.35. That is top to bottom, beryllium to radon, the ionic radii is increases, ionic radius is increases. Same from left to right, ionic radius is decreases. Ionic radius is decreases. Then the radius of chloride ions in the cesium chloride crystals, the coordination number is 8:8. Coordination number is higher than that of the, is somewhat higher than that of the chloride ion, and in NaCl crystal, that is the sodium chloride crystals, coordination number is 6:6. This is because of the fact that the cesium chloride crystals, each ion is surrounded by the greater number of ions as compared with the sodium chloride crystals, and this results in less of attraction between the different ions of cesium chloride crystals, and consequently the greater is the radius of chloride ions in case of 3 common structures, that is the A and B. A and B, it means that the one metal and non-metal, that is cesium chloride or NaCl. AB type of ionic crystal, that is ZnS, zinc sulfide, NaCl, sodium chloride, and CsCl, it means that cesium chloride, NaCl, are the 6:6 coordination number is generally taken as the standard, and the values are given as below. ZnS having the atomic coordination number is 4:4, NaCl 6:6, CsCl 8:8, and relative radii, that is the ionic radius between these two elements or the compound, ZnS 0.95, NaCl coordination number increases 6:6, that is the ionic radius is 1.00, CsCl coordination number 8:8, it means that the ionic radius is increases 1.03. Like this, if the coordination number is increases, the ionic radius is also increases by these given values. Then the third type is the covalent character in the ionic bonds. Covalent character in the ionic bond existing between the cations and anions, that is the number of cations and number of anions forming the ionic crystal decreases the measured inter-ionic distance, and hence the ionic radius is also decreases. It means that the covalent character in the ionic bond between the cation and anion, the cations, if the cations and anions are increases, then the ionic radius is also decreases. Ionic crystals is decreases as measured the inter-ionic distance, and hence the ionic radius is decreases. If the Na plus, it means that loss of one electron, the ionic radius is decreases. By gaining of one electron, ionic radius increases. Like this, if like this is the number of cations and anions, depends upon the number of cations and anions. Periodic variations of the atomic and ionic radius. In the period we discuss about the ionic radius is decreases. That is the lithium to fluorine ionic radius is continuously decreases. That is the internuclear charge is increases. And covalent radius is also decreases in the fluids. In groups, the covalent radius or the ionic radius is increases from top to bottom. That is the beryllium, magnesium, calcium, strontium, barium. A covalent radius is increases from top to bottom. Ionic radius is also increases from top to bottom. That is the number of cells are increases. It means that the ionic radius or the sealing effect, due to the sealing effect, screening effect, these factors, the ionic radius is increases and covalent radius is also increases. So this is the metallic radius, van der Waals radii, ionic radii, and the factors affecting the magnitude of ionic radii. First factor, we discuss about the first factor, that is the coordination number. Second one coordination number, then the second one is the covalent character in the ionic bonds. Then the variations we discuss about the variations. Some ions or the elements having the a lesser or greater, then in the period and in the groups. So this is the today's topic we discuss. Remaining topic we will discuss in the next lecture.